Hi everyone, welcome to the last session of this webinar. You know, syllabus we cover for this particular agenda. Okay, we cover these things: introduction to cybersecurity, introduction to machine learning, and introduction to Python. Right? And we were like in the last session we were like around data wrangling. Okay, we will see a bit part about Python, how to manipulate data, how to wrangle data by using Pandas library. Okay, so let's get started with our session. Okay, in the like yesterday, where were we? Okay, like we were about like data wrangling using NumPy and Pandas. Okay, see, we saw this all about NumPy library, and you guys let's go ahead with the array slicing. So guys, here you can see that this is nothing but the array slicing. As we saw the slicing in the list, slicing in the tuple. Okay, like how to get the access a particular amount of data from the list, from the tuple, as well as from the dictionary. But in the dictionary we use two keys, okay, to access particular values or particular data from the dictionary, right? And here you can see that array is very much similar to the list, right? And you can create array by using list as well. So like in the previous session we created the array by using list. Okay, and here you can see that again we are doing the same thing. Okay, np.arrange. But before doing this, okay, we need to import one library, which is this one. Okay, import numpy as np. Yep. So let's run this. Okay, to run this particular or to execute, okay, all our code. Because okay, yesterday we executed this particular line of code. Okay, then only we can able to create the different types of arrays, right? And now here you can see that, okay, first we'll have to import numpy library as np, and then we'll start creating the arrays. Okay, for slicing the array, to show you how to slice the array. So this is numpy array, you can say. Okay, now here you can see that, okay, this is a slice from the start, okay, till this particular index number. Okay, so here you can see that, okay, we'll be just accessing the first 5 entries or elements of our array. So with the help of this we just access the first 5 elements of the array, right? Here you can see that the slicing, okay, to the end from fourth index, right? So see, from fourth index you can see that the slicing to the end. Okay, this is the between slicing. Okay, you have to add the like the starting index number and the ending index number. Okay, and in between all the indexes value, okay, you will be able to access. Let's go and run this, and here you can go. Okay, now if I tell you I just wanted to just access the even number, or you can say that the even places. Okay, so here you can see that for that we'll have to add the we'll have to just put a blank rows. Okay, that's what we did over here. Okay, then colon, this is for the blank column, because you can see that this is the row, this is the column, you can say, because this is a one dimension. Okay, so you can see that the first index number, last index number, and the difference. Okay, we are just just analyzing all the array. Okay, means we are considering all the array by using these two columns. Okay, with the space here you can see, and the two is nothing but the difference. Okay, we are just one after another, like we'll take the 0, then 2, then 4, then 6, like this. Okay, let me show you. Let's go and run this. Here you can see, okay, 0 2 4 6 8, right? Okay, if I wanted to if I wanted to go with the the first index and then the difference. See, this is the first index, okay, then the difference 2 means just accept the middle one, go with this, accept the middle one, and go with this like this. So you will find that, okay, will just access, okay, all the odd numbers, right? And you can reverse the array by using this, by using negative indexing, right? Okay, now this is how you can do the multiple, you can manipulate your data, okay. And this is nothing but the concatenation, okay, like we did append method in the list, okay, like we append the two list to tuple by using the, by addition operator. And in the list, okay, there is one uh, function which is inbuilt function, which is nothing but the append itself, okay. By using append, you can be able to append the two different list, okay, or you can be able to merge the two different list. That's what we do over here, okay. Here you can see that the np.array, okay, and we are using the concatenate function, okay, to concat these three arrays, okay, which is nothing but the x, y, and z array. Now here you can see that, okay, this is just the list, okay, this is just the list. So here you can see that, okay, instead of array, if you can use the list, then only it is sufficient to create or to merge or concatenate the arrays. Because with the help of np.array you can create the array, but instead of using array in the beginning, okay, you can use the list, okay, instead of array, and you can even concatenate the arrays, okay, because of this np.concatenate function. Okay, let me show you. Yeah, you can see that we just concatenated, means we merge the three different arrays, okay, and we converted into as a one array, right? Now here you can see that, okay, this is a two-dimensional array. Let me show you. Let's go and run this. So here you can see. So here in the array you can see that this is the first row, this is the another row. And for separating the each row, okay, we added the square bracket at the beginning of row and at the end of the row. And here you can see that by just using a comma, okay, you will be able to separate the rows, okay. Means array will understand that yes, this is the first row, this is the second row, right? And that's how you will get the matrix. You can say that the two-dimensional array, okay. Now here you can see that np dot concatenate, agar again we are, okay, concatenating the this grid with the grid itself, okay. Means we are, instead of copying, you can see that we are just, okay, will be getting a double matrix, okay. But here you can see that we merge the dimension, okay, instead of adding the numbers, okay, because it's just the merging, you can say. Yeah, this is nothing but the concatenate, okay. If we go with the axis equal to 1, so you can say that it's a row wise, okay, you can see. Yeah, it's a row wise concatenation, right? It's a row wise concatenation. Instead of adding, you know the, like the one after another, okay, you can see that it's a, you know one, then you can see that after one completion of one row, you will see that this the second matrix row, right? This is how you can go ahead with, okay. Now after this, here you can see that, okay, here we are creating the array, okay, one dimension array, two dimension array, and we are using a vertical stacking, okay. Stacking is a one kind of, again, concatenation, okay. And you can use this, okay, to concatenate the, different dimension data, okay, you can see, okay. Now it's a vertical stacking, which is same as this one, okay, np dot stack. And by default, value of axis equal to 0, okay. Here you can see that, okay, I didn't mention any axis parameter, so the value of axis is 0 over here, okay. And that's the same thing we are doing over here, okay, vertical stacking, in the vertical stacking, right? Now here you can see that this is going to be the horizontal stacking, okay. This is going to be the horizontal stacking. We created the one matrix, okay, and here you can see that we are concatenating or stacking this matrix with the grid matrix, which is our this matrix. Okay, this is a grid matrix you can see over here. Yeah, so this is how you can do the stacking. Okay, either vertical stacking or horizontal stacking, right? Okay, and here you can see the Z matrix, okay, or you can see that the Z array. Okay, here you can see that the order of this matrix is going to be the 2 cross 1, right? And here you can see that after this, okay, let's go ahead and just understand the splitting methods, how we can split the arrays. Okay, so this is a X array we just created, and the values of X arrays, you can see that the 0 to 9 total 10 values are there, and we are using the array underscore split method. Okay, the X, and you can see that the how many parts we want. Okay, we want 3 parts. You can see that this is the first part, this is the second part, this is the third part. Okay, that's how we can split our array. Okay, here you can see that this is again another splitting. Okay, and you can again see that we are just using the multiple variables. Okay, you can see that we are creating the multiple arrays. In short, like here we just mention the one value or one name of the array. Okay, this is a we just splitted inside the array. Now here you can see, okay, we just created the 3 new arrays, right? We just created the 3 new arrays from the one array, which is nothing but X array. Okay, and you can see that at the particular index, okay, we just splitted our array. Like at the third index, you can see that at the third index we splitted our array first, and at the sixth index we just splitted our array secondly, right? Okay, this is how we can do this splitting, okay, in the array. Now let's understand the reshape. Okay, this is a we are this is a okay, let me first show you. Okay, this thing, let's go and run this. So here you can see that the we got the array from of the value 0 to 15, right? Okay, if we use the reshape 4 cross 4, which means that okay, we'll be able to convert this array from 0 to 16 values to 4 cross 4 two-dimensional array, or you can say that the matrix. Okay, let's go and run this, and you can see over here, okay, it's a 4 cross 4 two-dimensional array, or you can simply say that it's a matrix, right? Okay, you can even go for printing this, so you will not be able to see the array name in the output, right? Now after this, here you can see that it's a vertical split. Okay, you can even go for like we stack the data vertically or horizontally. Okay, in the same way you can stack the you can split the data vertically or horizontally too. Okay, like here you can see that we'll try to split the the grid matrix, which is the this matrix, okay, from the second index, okay, or a second row. You can see that we'll try to split this like this. Okay, first matrix is this, which is upper matrix, and this is the lower matrix, and here you can see that the upper and lower. Okay, let me show you. Yeah, you can see that now this is the upper matrix and this is the lower matrix, right? Okay, this is a horizontal split. Okay, now in the horizontal split you can see that we just splitted our data from the second column. You can see that the first matrix is like this and second matrix is like this. Okay, so this is how we can okay do multiple things. We can manipulate data by using numpy library. Okay, and now we'll quickly see the pandas, how we can use the panda to manipulate the data. Let's go ahead with the pandas. Okay, here you can see that okay, in the same way as we imported the numpy package, okay, we are doing the same thing over here with the pandas. We are importing pandas as pd. Okay, and it's just the short name. Instead of using the pandas everywhere, okay, like this, okay, you can use a small name which is nothing but the pd. Okay, pd dot data frame. Okay, because in the pandas you will find that the multiple functions you can use by using pandas. okay, like this, okay, dir, okay, pd. Let me show you. Yeah, you can see that the multiple functions we can be able to use. Okay, see these many functions, so many functions are there. Okay, see these many functions are there, means you can do many more things, multiple things, okay, with this. Okay, right now, okay, what we are doing over here, okay, after importing the pandas library, you can see that, okay, we are creating the data frame. Okay, we are creating the data frame, right? Okay, so for creating data frame, what we need, okay, we need dictionary. Here you can see, okay, by using curly bracket we just created a dictionary with the key and its value, okay, by using the list. Okay, here you can see that we just added the number of values for particular key, which is country, okay, by using a list. Okay, same with the rank key and their numbers, okay, by using a list. Okay, and just by using pd.data frame, okay, pandas is very much capable to convert this dictionary into a data frame. Okay, so as we saw yesterday how we can see the dictionary, okay, so let me show you how we can see the data frame. Okay, data frame, it's in a table format, you can see. Okay, but not a dictionary. Okay, you can't see dictionary in a table format, but you can see the data frame in the table format, which is very structured data, you can say. Yeah, okay, yeah. So after this, okay, here you can go ahead with the a basic simple statistical analysis. Okay, which is a also you can say 5-step summary. Okay, let's go and run this, and here you can go. Okay, in the python you will get the count, okay, which is not included in the 5-step summary. Okay, but you will see that the values are there. Okay, or you can see that the 5 rows are there, the mean for particular rank, because okay, when we are describing the data, which means that we only describe a numerical column. Okay, we can't describe a country, because here you can see that each country is a different. Okay, and we can't say that yes, we can't add the Russia plus Colombia like this. Okay, okay, but this is a number. Okay, so we can find out the mean, we can find out the standard deviation, minimum value. Okay, just from the country name we can't say that the Russia is higher, Nigeria is smaller, like this. Okay, after understanding or after seeing their rank, so we can say that yes, okay, here you can see that the the mean value, okay, of the rank, standard deviation of the rank, minimum value, quartiles, okay, 25th quartile, 50th quartile, which is also known as median, okay, and 75th quartile, and the maximum value. Okay, you know that maximum value is 130. Okay, like this. Okay, so okay, we'll talk about more on this, okay, when we move to the applications of machine learning, okay, in cybersecurity. So that's why let's quickly understand these things, okay, and then we'll move ahead. Yeah, so let's go ahead and understand the information about the data, like its type. Okay, is there any missing value present or not? Okay, let's say here you can see that the total number of entries, which are 5. Okay, total number of columns, which are 2. The data type of each column, first one is a object column, because you can see that this is a text column. Okay, in terms of data, say data type, you can say that it's a string column. Okay, but when it comes to data frame, so if the column contains the text value or the text data, so you will have to say that the data type for this particular column is nothing but the object, right? And then data type for rank is going to be the integer, because the rank is a numerical data. Okay, and you can see that out of 5 entries, okay, first column contains 5 non-null data points, which means you can say that it's a you know the no missing value present in the first column, same in the second column too, because there are 5 entries in the data set, and you can see that in the first 2 column you can be able to see the five entries, which means that there are no null values. You can also check over here. Okay, like in the if the data is quite big, okay, if it's a real data, okay, so you will find that the many missing values will be there. Okay, so for that we can, okay, understand this, we can check this by using the information. Okay, you can be able to find out are there any missing values in the particular column or not by using this. Yeah, great. Now after this, okay, let's create another data frame, okay, by using dictionary. Okay, we just created another data frame. Okay, here you can see, and this is how our data frame looks like. Okay, first column is a group, second column is ounces, and here you can see that the index value 0 to 8. Yeah, and now how we use sort method for list, for tuple, for array. Okay, in the same way, here you can see that, okay, we can do the same thing. Okay, we can do the same thing by using the sort values. Okay, sort values. Now we have this data, right? This is our data, and we are applying sort values, okay, on particular column, which is ounces. Okay, because you can understand, guys, okay, in the data set, okay, there are multiple columns. Okay, so if I go with the sort values, so by using which column I have to sort my data frame, right? Like in Excel sheet as well, if I wanted to sort the data set, okay, so we have to first define on which column first we have to go with. Okay, if you go ahead with the the rank, okay, so you will have to first decide, yes, first we'll have to sort this column, so automatically you will sorting all your data rank wise, right, or your rows rank wise. Understood? So here we are doing the same thing. Okay, by ounces we are using the ounces because it's a numerical data and it's very easy to sort the data. Here you can see that again another parameter which is nothing but ascending and in place equal to false, which means that, okay, we are not be going to you know update this term. Okay, we are not be going to update this data. Okay, this data is uh, as it is. Okay, we'll create the just to show you. Okay, we'll try to apply this particular method just to show you. Okay, we are not making any changes in this particular data, that's why in place equal to false. Yeah, if in place equal to true, which means that, okay, apply changes in the original data set, right? So that's again a very important parameter. Okay, you can even note down the the functionality for this particular parameter. Okay, because we'll be using this parameter uh, in a like the in a multiple places. Yeah, let's go and run this, and here you can see that first our data is like this. Now here you can see that. Now basically, okay, how to check we sort the data or not? So this is the data with the index value 0 1 2 3 4 5 6 7 8, right? Now here you can see that we just sorted the data into the ascending order 3 3 4 5 6 7 7.5 8 and 12, right? And see their index value 16073. Okay, which means that yes, we did correctly. Okay, we sorted our data into the ascending order by using the ounces column, right? Yeah, so this is how we can do the manipulation. Okay, we can even go for the multiple column by using multiple column. Okay, first we just go and ascend the use the group to sort our data into the ascending order. Okay, then we'll use the ounces to sort our data into the descending order. Okay, and in place equal to false, which means do not make any changes in the original data set. Okay, so let's go and run this. Now here you can see, okay, we just apply a the first group. We just sorted our data by using group column, okay, into the ascending order. Okay, ABC, right? Then we'll use the ascending ounces column for the descending, so that's why you can see that the 12 for you can see that, okay, this thing. Okay, And why you not able to see this? Okay, because here you can see that then group will affect, okay, like ABC. Okay, that's why. Okay, now after this, here you can see that, okay, we are creating another data set with multiple duplicates rows. Okay, like this. Okay, we are creating a dictionary which is saying that this is a key one. Okay, and here you can see that in the key one you will find that the one, how many times one repeated, three times, how many times two repeated, four times. Okay, we are creating the key two, and here you can see that, which means that, okay, after running this line you will be able to see that we just created multiple duplicate rows. Okay, like this is a, this is a duplicate row, with this 3 and 4 is a duplicated row. Okay, the fifth and sixth is a duplicate row, right? Okay, this is how we just created the duplicate rows. Okay, now if you are not able, you are not able to, get this thing. Okay, so let me sort this thing. Okay, so you will understand. Okay, by K2. So here you can see that, okay, this 1 1, okay, 1 2 1 3, which is not duplicate, then 2 3 2 3, which is duplicate one, and 2 4 2 4, which is duplicate one, right? So you can convert your data, or you can sort your data to see that, are there any duplicate values or not. Okay, and simply, instead of, if the data is quite big, so instead of, checking whether are there duplicate values or not, because see, if the data is quite big, let's say 100 columns are there and thousands of rows are there, so how you can check each and every row is duplicate or not, right? You not able to just find out even two rows which are duplicates. Okay, so here in Python, okay, you can simply do one thing. Okay, if you don't want duplicates, use drop duplicate function. Okay, data dot drop duplicates. So first, how many, how many data points are there in the, in the data frame, in the row, in the data frame? Total 7 data points are there, right? See, first row, second row, so total 6 index values are there, which mean total 7 data points, because 0 index is also there in the data frame. Yeah, so after dropping this, here you can see, okay, we just remain with only 6. Yeah, only 6, not only 6, only 5. Okay, because we just drop this particular row as well as this particular row. Okay, because these two rows are duplicate and these two rows are duplicate. Okay, so we drop one rows, okay, from this one row and from this one row. Yeah, so you can see that. Okay, it's a very simple method, guys. Okay, you don't need to check your data, you don't need to see your data, okay, to drop your duplicates. If you don't want duplicates, use drop duplicates method, and you will simply, able to drop duplicates. Okay, now here you can see that, okay, it's a subset K1. Okay, now here drop the duplicate by using the subset K1. Okay, I just, explain this particular term, and here you can go. Okay, by using K1. Okay, in the K1 you can see that the 1 and 2 values are there. So now the Python will only search for this particular one, are how many duplicates are there, the 1 and 2. So Python automatically removes these two rows. Okay, and for these two, Python again check how many duplicate rows are there. Okay, so you can see this is the duplicate row. Okay, for this, because we are only checking the data by using K1 column. Yeah, that's why you can see that we remain with only two columns, right? Okay, that's how we can use a drop duplicate function for dropping the duplicates value in our data, right? Now here you can see that, okay, we are creating the, the, again, another data frame, right? And here you can see, okay, just for, creating a data frame, let me create, okay, once again. Okay, and here you can see that what we are doing over here. Okay, you can see the food and ounces. Yeah, the food, and you can see that the, again, in the price you can say. Okay, so now, okay, what we are saying over here, okay, we are saying that, okay, this particular is a meat. Okay, you can see that the meat, okay, of which animal, of which animal. So here you can see, okay, we just created a one dictionary to show you, okay, this particular meat is from the pig, like this particular meat is from the cow, this particular is from the salmon, which is fish, okay. And here you can go, okay, we just created a, we just define a function meat to animal, okay. And with the help of just meat to animal, here you can see that if the series, okay, like if the food is bacon, so we can return the animal name, okay. So we can simply just created a one function meat to animal, which will tell us this particular the meat is from is of which animal, okay. Now here you can see that we just created a function, okay. And it's very easy to create a function. I show you yesterday, and here you can see that we used a double equal to, okay, symbol. So we have another operator as well, which is nothing but the is operator and is not operator, right? So here you can see that instead of using is operator, you, okay, mostly people, mostly developer professionals, okay, are using this particular double quote symbol to check whether the particular food is check the equality condition, right? Now here you can see that why we did this all this thing, okay, because why we created this particular thing, we have the data frame, right? Now, is there any reason to create this all? Okay, yes, there is a reason to create this all, okay. If you wanted to, let's say, add a particular column and you have thousands of row, so instead of manually editing all the rows, see, we know that just after looking at the meat, we can simply say that yes, it's a meat of pig, it's a meat of pig, like this, it's a meat of salmon, okay, we can simply say this thing, right? But if there is a hundreds of column, thousands of rows are there, so at that time, how you can manually add those values or add those data in your data frame? So instead of adding this data, you can simply go ahead and create the dictionary, go ahead and define a one function which can convert your data from the the data you don't want and the data you want, you wanted to create that particular data, okay. So now here you can see that we are creating a new variable. In short, we are creating a new column, okay, which will be adding into the data frame, okay. So here you can see, okay, data animal, okay, we are saying that data food dot map is nothing but a mapping function, okay. We are using a, we are applying a string dot lower function as well as map meat to animal, which means that the apply this function on this particular column, which is nothing but the food, okay. So let's go and run this, and now here you can go, okay. We just created a new column, okay, by using a food column. Here you can see food column, we are mapping into the applying a lowercase first, because many time you will find that Python is a very case sensitive. So sometimes, okay, you can see that the capital P is there, okay, pastrami, and here you can see that the same word but with a small case, in a small case, pastrami, okay. So it will be, Python will recognize that these are the two different words, okay. To avoid that kind of mistake, okay, to reading the data, okay, for this particular function, to avoid that particular problem, okay, we just apply this particular lower function first, and then we map the meat to meat, meat to animal function, as we created this function over here, yeah. So this is how you can create a new column, okay. Now, okay, many a time you don't need to create a function for creating a new variable, okay. You can even applying the operators, like subtracting the data from one column to another column, you will get the third you know third column, which is your new column. Let's say if you have a uh, uh, which is this, okay, age and year of experience, okay. Okay, age and not age, okay, you can say that the education and year of experience. Okay, so you know that you can convert the education into the, you know, the age, because let's say if a person is completed his graduation, so which means that, okay, he's at that time, when he was completed his graduation, so at that time, you know, the person's age, okay, would be around, okay, you know, 20, okay, 19 to 20 years, yeah, around that, yeah, or 21, okay. So you can estimate that age, okay, and you can add that age into the number of year of experience the person has, okay. So total addition would be the age of that particular person, right? Okay, that's how you can create the new variable too. Okay, so you know, age is a, you know, again the very important variable, okay, for the data, okay, to analyzing any data, because as age is increasing, so you will find that the, you know, psychology of the person is also changing, okay, a bit. Like in the e-commerce sector, it is very easy to understand, you know, to know the age of the customer, okay. Then e-commerce customer will suggest the products, okay, like like the different person with the same age they are purchasing, like the one person is of a 40 years old, okay, like he is purchasing particular item, okay. And then the same person with the same like another person with the same age, okay, he will be on a, you know, he came to the same e-commerce website, so e-commerce website used to suggest the same product though that person purchased, okay, that person brought, okay, from the e-commerce website, okay. So like that you can see that some similarity, okay, of purchasing the product, okay. So it's a, you know, some psychological, you know, phenomena, psychological term, okay. It's a kind of marketing term, okay. And you can use the same thing over you know, by using, okay, if you know that, so you can be able to if you don't know the age of the customer, so you can create that, okay, by just understanding his education and the number of year of experience he has, okay, into the industry, like if he is working, okay. Like there are another way as well, okay, to, you know, get the age of that person, yeah. Now guys, after this, here you can see that, okay, it's again very interesting, you know, the attribute you can say, or you can say that the again any one function which is very much popular, okay, in Python, which is nothing but the lambda function, okay. What is the use of lambda function? So here you can see that, okay, we are saying that, okay, this is going to be the lower, we just assign a one name for a lambda function, and we are saying that lambda just, okay, just by using a lambda word, so we just creating a lambda function, okay. Now what lambda function does, here you can see that, okay, this is saying that x and colon. Now here you can see that we are applying the x dot lower, which means that we are converting our data, see, this particular column, okay, let's say, because this is the one column we have in the original data frame, and we wanted to convert this data frame for into the lower case, because here you can see that the bacon, okay, this is nothing but a capitalized word, this is passed from is a capitalized word, okay. So this kind of data if you have, so at that time, okay, instead of using this term, okay, see, this term mapping this lower, so you can even use the lambda, okay, dot lower, okay. And here you can see that, okay, we just apply or I mention the one word, okay. And here you can see that, okay, because we are just applying the lower method, that's why here we just assign a one word which is nothing but lower. And here you can see that data dot food, okay, here we are just you know, extracting the food, and we are making the changes into this particular column, okay. We are saying that data and food, okay, which means that, okay, this particular code is saying that, okay, we just say selected the food column from the data, right? dot apply lower, okay, which means that we are applying this particular lambda function on this particular column of the data. Yeah, so here you can see that after applying, you will find that all the food, okay, the lay, we'll be converting the words into the lower case, okay, all the letters into the lower case. So here you can see that we are again creating, because we just created the animal one column, so again we don't have to, okay, we can't create the same column, okay. If we create the same column again, the main thing is that, okay, the purpose for doing this, okay, to show you the another function, how we can do this thing, how we can apply lambda function, okay. That's why we are using animal 2, okay. You will get the same column like this animal, okay, because it just the we just change the name, because if the name is same, so you will find that Python automatically update this column, not just create one new column. So that's why we'll have to add the another name. You can add any other name instead of this, okay, but to understand, okay, these two columns will be same, this animal 2 and animal 1 will be same, because we are doing the same thing over here, okay. We are applying a meet to animal function, axis equal to column, which is nothing but, okay, we are, okay, we'll be getting a new column as the animal 2, and here you can see. So this is how you can use the multiple functions. That's how, okay, like in Pandas library we have multiple functions, and it's very powerful library, okay, to manipulate your data, to create a new data, right? So you will have to understand the Pandas library if you wanted to learn Python, if you wanted to implement machine learning in any domain, not even in cybersecurity. Uh, you can analyze the healthcare data, robotics data, accounts data, finance data, or any data, right? Now here you can see that, okay. Now what we are doing over here, okay, we are saying that data dot assign new variable, okay, and data ounces multiply by 10, okay. We are creating, again the new variable, okay, because with the help of assign function here, again we'll be able to create the new column, okay, which is saying that the ounces multiplication multiply by 10. So you will find that the ounces multiply by 10 column over here. So see, it is very easy, okay, to create the new column, okay. But like, you will have to know, okay, you should know that what kind of column you will have to create, okay, what kind of column you want in your data set to analyze your data, okay. So if you know the problem statement, if you understand the problem statement, it will be very easy to create your data if you have a very small number of columns as well in your data. So you can create multiple columns from your data as well, okay. Yeah. So now after this, okay, let's go ahead with, the dropping the columns, okay. Like, see here, we are dropping the columns by using a drop method, okay. As we saw how we just drop duplicates rows, in the same way we are dropping the duplicates column, because here you can see that, or many time, instead of dropping a duplicate column, because here we have a duplicate column, it's not necessary that in this all the data set you will find the duplicates column, right? Okay, many times you will see that the one data contains some ID, yeah, but ID column is not important for our analysis. So at that time, okay, you can remove that column. So you can use the drop method for removing the ID column. Yeah, sometimes you don't want the name column of the customer, because name is not, like, you can't analyze the name data, okay. You can't analyze the name data. If you wanted to build a model, so there is no need of names of the customers, okay. You will have the information of the customer, not the name only. Yeah, so that's why for dropping the columns, so, and even rows, so you can use the drop method. Here you can see, okay, we just mentioned the column axis equal to columns, which means that we are just dropping the column. And see guys, here in place equal to true. Now here you can see that, okay, here, okay, we'll just, okay, here, where were we? Okay, we were talking about this in place equal to true, okay. So like we are dropping the data, okay, particular column, okay, with access equal to column, which is nothing but now here we are assigning that we are dropping the particular column, okay, and in place equal to true. Okay, now after this, here you can see that why I added this particular parameter in place equal to true. Okay, as I show you, as I explore this particular term, okay, over here, okay, at the time of this particular term in place equal to false. Okay, when we created the when we sorted the data set at that time, I just use in place equal to false. Okay, at that time, I told you about this, okay, why I added this parameter. Okay, here you can see that, okay, why I added this. Okay, because now, okay, we wanna drop the particular animal 2 column from the original data set. Okay, as we created and as we made changes in our data frame. See, first data is like this. See here, first we created the data frame like this, food and ounces columns. Okay, now we added one more column, animal, right, in the original data frame. Then we added one more column which is nothing but animal 2. Then here we added one more column which is a new variable, right? And here now we are looking for how to drop column. Okay, so that's why now instead of in place equal to false, which means instead of making changes in original data set, okay, let's drop the data, okay, from the original data set. That's what we are doing by using in place equal to true. Yeah, so let's go and run this. So here you can see that first our data, original data was like this. Now after dropping, you can see like this. Yeah, you can see like this. Yeah, understood. Okay, here you can see that here we didn't mention, okay, we just we didn't mention the data. If you mention the data, you will find that the new variable will be here, okay, in the original data frame, but we just assign, not we just put that into the original data set. So you'll find that the original data set only this much. Okay, and after dropping the animal 2, you will find that, okay, we just remain with the 3 columns, okay, which are this one. Okay, which means that we just drop the last column, which is the animal 2 column. Yeah, again we are creating one array in the data frame, and we are just putting the index. Commonly you can see that the index values are 0 1 2, but manually you can edit the index as well. Okay, right here we just edited the index, okay, by using the index parameter and the column names, okay, like 1 2 3 4. Yeah, let's go and run this. That's how you can create your data as well. So see, now here you can see that this is my first column, second column, third column, fourth column, and these are my index words, right? Okay, that's how you can create your data frame. Yeah, now here you can see that, okay, here you can see that, okay, we are renaming the function. Okay, now how, what is renaming the function? Okay, because here you can see that if you wanted to rename your column or indexes. So see, we just created the 1 2 3 4 and Ohio, Colorado and New York. So you can see that the now I just wanted to change the index of index Ohio from the San Francisco. Okay, San Francisco, and column from 1 to 1p, 2 to 2p, like, and in place equal to true means make the changes in over here. Okay, so let's go and run this, and here you can go. Yeah, so that's how you can make your changes. You can rename the function by using the rename function. Yeah, so here you can see that, okay, you can even go for renaming the data. You can even apply the this is the one function, rename, and inside the rename you can even apply the further function, which is nothing but the upper. Okay, these are the some formats of the string. Okay, you can convert your string data into the uppercase, lowercase, title case, like this. Okay, capitalize. Okay, there are multiple cases. Okay, upper, lower, capitalized, title. So here you can see, let's go and run this, and here you can see we just converted columns. Okay, we just converted the columns into the titles. Okay, you can see, and the index as the uppercase. So we just converted all the index letters, okay, words letters, into a uppercases. Okay, Now here you can see, okay, this is going to be the ages. We just created a list, let's say, okay, and here we are just creating the bins, okay, again the another list, and we are using the cut function of pandas library. Now cut function is nothing but we are creating the bins, okay, of 18 to 25, 25 to 35, 35 to 60, 60 to 100, and here you can go. Huh? So here you can see that, okay, we just created a one a interval type, okay, or a bins you can say. Okay, this is the first bin, because you can see that 20 will be inside in this particular bin, okay, 25 22 will be inside in this particular bin, 25 will be inside this in this particular bin, but 27 will not inside in this particular bin. So that's why you can see that the change, okay, 25 to 35, right? This is how the 25 to 35 bin value is there, which is again you can say that the interval. Okay, if you are if you are aware about frequency, okay, like at the time of creating bar plot, so you will find that the age interval, okay, like 10 to 20, 20 to 30, 30 to 40, okay, we are doing the same over here by using the cut function. And here you can see that right equal to false, which means that you will be getting the this is a open end intervals and this is a close end intervals. Okay, you can see that. Okay, so which means that, okay, at the first you will find that the parenthesis, but at the end you will find that the square bracket, which means that the 18 is excluded from this particular range, but 25 is included. Okay, but here you can see that the 25 is excluded and 18 is included. Okay, that is how you can this is a open end interval and close end interval. Yeah, interval is you can, okay, change the interval size as well, okay, depending upon the bin value, because here you are setting that, okay, first you will have to set the first bin, okay, from 18 to 25, means you just set the size of the bin. The second thing is that this is my second interval, okay, 25 to 35. It's in our hand, because we are doing it, we are saying that yes, do this, okay. Okay, so this is just the example, okay, not a exact situation. Okay, if you wanna create the same size of the bin, so you can even do that, okay, like the 15 to 25, 25 to 35, 35 to 45, 45 to 55, okay, like that you can try it out. Yeah, now after this, here you can see that the value counts. Okay, now you can see that the cats. Okay, so let me run this. Okay, so here you can see that we just created the categories, right? That's why just the short name. Yeah, so cats. Okay, and here you can see that after getting the cats, okay, this is my frequency distribution. Okay, so you will find that, okay, the interval and how many numbers, okay, will be there in the particular interval. So you can see that the frequency means in the ages, how many ages are there, how many ages will lie in this particular interval, how many ages will lie in this particular interval, how many ages will lie in this particular interval. You can say that it's a frequency, right? It's a frequency. Okay, and in short you can say that it's a frequency distribution for this particular age data, right? Okay, now after this, okay, here you can see that the value count, again we are doing the same thing. Okay, the again the bin names, okay, we just created a bin name: youth, young adult, middle age, and senior citizen. Yeah, so see, this is going to be the youth, young adult, okay, you can say this is going to be the middle age and the senior. Okay, just we just setting the bin names. Okay, so here you can see, yeah, instead of showing you the bin name, the intervals of ages, okay, now it's very easy to read the data, right? So you can say that now, can you say that yes, we just converted data into readable format? Yeah, how many people, okay, how many people, okay, those who are youth, those who are young adult, those who are middle age, those who are senior. So from this, okay, from this, okay, you can say that yes, it's a youth, okay, but you can't, okay, like it's very difficult to count, okay, it's very difficult. Let's imagine there are 1,000 data points, okay, and I told you I give you one range, and okay, I tell you that, okay, just count the number of how many the values which will be lie in this particular interval, let's say 15 to 25. Okay, so it's not possible to count you will count for 1,000 data points and you will get the number absolutely for sure. Okay, but what if you will have the data in millions? So at that time you will have to use this kind of technique, okay, to convert your data, okay, into the frequency distribution and get the count for that particular interval, right? Okay, and now it's a data in a readable format. You can read the data, okay, you can tell something out of the data. Okay, you can say that yes, now data is some showing some info, giving you some information. Okay, now the value counts, again the cumulative sum comes, sum function is there, okay, cumulative sum. Okay, what we are doing over here, okay, this is a new cats, again this thing, okay, this thing, and we are finding out the cumulative sum. Now what is cumulative sum, which is we are adding the 5 plus 3, which is 8. Okay, so you will be getting the one new column like this, 5, 8, okay, 11 and 12. Okay, let me show you. Yeah, 5, 8, 11, 12. Okay, because we just created a data, okay, not store in the, okay, we haven't stored the data. Okay, just to show you how you can do this. Okay, by just adding a particular name equal to this, let's say x equal to this, so you will see that now, okay, you are storing the cumulative sum as a x. Okay, but we don't want to store this. Yeah, because it will take the memory. Yeah, it will increase the size of your this file, notebook file. Okay, that's why. Okay, you can do that personally, okay, to for learning purpose, and you can check the size as well. Okay, it will must increase your size of notebook. Yeah, now here you can see that this is another your data frame. Okay, you just created your data frame by using a random module. Okay, by using a random module, you just took the 5 random numbers. Okay, and you will see that the random numbers which are totally random, okay, any numbers in between minus infinity to plus infinity, you can see that the 0, 0 point, some in points rational numbers, you will find some negative, some positive. Okay, and the key 1 and key 2. Now here you can see that now we are about to end this data wrangling part by using pandas. Okay, because we saw the numpy above. Okay, so here you can see that the now we just remain with few functions, okay, like this, and from here we'll be exploring the ml, so we'll go into our applications. Okay, so let's quickly go through with this. Okay, because again this is again the important part, because if you understand this, okay, you will find that as like in the webinar, okay, we are doing the same thing, okay, as we will be doing in a data science project in the future as well. Like some like out of you, some guys will be working as a some a cybersecurity analyst, okay, or a data scientist, data analyst. Okay, whatever position, okay, you have, but surely you will be working with the data. Yeah, so at that time, okay, if you get any project related to data, so around 60 to 80% of the time you will have to work on to manipulate your data, to just finalize your data in short. Okay, so to finalize your data, so you can do these things. Okay, so that much time we are understanding this thing in the webinar too. Okay, and then you will find that at the time of application, to see the application, it will be very easy. Okay, because we'll not be go into the deeper to understand the math behind the algorithms, because it will be very critical part, okay, to understand the math behind the applications, the algorithms of machine learning. Okay, so you know we'll see how to implement the methods only. Huh? in the in the like after this, after completion of this data wrangling using Python pandas. Yeah, now here you can see that, okay, what we are doing, okay, we are applying group buying. Now what is exactly group buying is, okay, now we have the key one and key two, data one and data two column, right? Now here you can see that we are just accessing the data one column, see data one column, and we are checking that, okay, we are just applying the one more function which is nothing but the group by, and we are saying that yes, and group by this particular data one by using the key one which is nothing but the A and B. So which means that, okay, we are group buying, which means that we are group buying this data one into the two categories, okay, as we have the two categories in key one like A and B only, okay, which means that we are just sorting the data into the two categories of key one which is nothing but data one, and we are finding out the mean. Okay, so you will be getting the mean of data one in terms of two classes or the two categories of the key one A and second B. So let me show you. So here you can see that the key one, okay, you will see that the mean for category in the A of data one, and the B for the mean for category B, yeah, of data one. So you will find that the mean for category B is this, and mean for category A is going to be the sum, okay, of these numbers, okay, these and this divided by, okay, sum of these three numbers divided by 3, you will get the mean. Okay, that's how you can, okay, group by this. Now, okay, why I'm showing you these small examples, because, okay, if you try to imagine the very big data set in the beginning, so it will be very difficult to understand the logic behind the functions, okay, these functions. So that's why, okay, to understand this function, okay, you will have to go with small data set. Okay, absolutely, for sure we'll be going with high number of data set. Yeah, but here you can see that, okay, to understand the concept logic behind the functions, okay, that's why I show you this, the small data set. Okay, now here you can see that, okay, now you can deal with the date time data. Okay, this is the date range, you can see that the date range, okay, this is my date, okay, 2023-0101. Okay, this will be going to be the 1 January of 2023. Okay, periods equal to 6. Okay, now here you can see that, okay, what we are doing, okay, we are just finding out the random numbers. Okay, and you can see that the 6 cross, you know 6 cross 4. Okay, total how many rows are there? 6 rows are there, 4 columns are there, that's why 6 cross 4. Index are nothing but the dates, and the dates we just declare over here. Okay, these are nothing but the dates starting with this particular value. Okay, this particular date, which is nothing but the 1 Jan 2023, then second, third, fourth, fifth, sixth, right? Okay, and the columns which is nothing but in the list, okay, ABCD. So you will get the column names, okay, ABCD. Yeah, this is how you can create your data in a small line of code. Okay, no need to edit that data, manually edit that data. Yeah, now here you can see that, okay, uh, how to extract the data, okay, from the data frame as we saw above. Okay, in the same way you can get the you know the data like this. Okay, this will be, okay, saying that, okay, you will be getting the first 3 rows of your data. Okay, here you can see that again, the this will be, okay, this will give you the again the the first 3 entries of your data, not the fourth one. Okay, because the fourth one is excluded one, this one. Okay, you will get the first 3 rows. Let me show you. Okay, okay, so see here. Okay, yeah, so see basically, okay, if you mention the as we mentioned, the dates, okay, as the index. Okay, so here, okay, we got this. Okay, here also you can see that, okay, in the data frame, okay, we'll be getting this, okay, the last index as well. okay, the fourth one. Now here you can see that, okay, now on the basis of columns, okay, you can see that this is your data, and on the basis of column you will be getting the, you know, all the rows which are there in your column. So see, we just access, okay, we just uh, just collected only two columns out of four column, okay, means we can be able to get the two columns, okay, out of the four columns, okay, with the help of lock method. Okay, this is nothing but the location. Okay, you can see that the lock method, again the same thing, again the subset of the data. Okay, see, from these many rows you want and only this much column you want. Okay, so you will get the data like this. Now this is nothing but the iLock. What is the difference between location and iLocation? Okay, this is nothing but the location here. Okay, you are going to, you know, add the name of the columns. Okay, you can see that the index name as well. But here with the help of iLock, which means you now you will have to use the index number. Okay, that's the difference between the lock and I location, means which is nothing but the index location, and this is just the location. Okay, that is the two main difference between the iLock and I lock method. Yeah. So now here you can see that you will be getting the, you know, the third row. Okay, the, you know, see, this is how, okay, index third row. Okay, so you will see that, okay, you will getting the fourth, you know, values of a b c d. So final data, okay, original data is this, and you will be getting the, you know, 0 1 2 3. So you will get, okay, we got the values of this, 0.29 to 0.83. Okay, you will find that 0.29 to 0.83. Okay, okay, many times it's a bit confusing, okay, when it comes to the lock and iLocation. Okay, you will find that if you are using the lock, you will be getting the, okay, the last value as well, because you are mentioning the name of that. Okay, that's why if you are going with index, so you will not be getting the last index value. Yeah, that's why. Yeah, so like here, okay, fourth index is excluded, to second index is also excluded. Okay, so if you count the 0 1 2, so which means that 0 1 2 total three columns are there, but you will get only two columns, not the three columns. Okay, here you can see that the 2 3 4, which means total three rows are there, but you will get the only two rows, two and third row. Yeah, let me show you. Yeah, see, two and third row, and a and b column, only two column instead of three column. Okay, because index, last index is nothing but excluded, okay, from the analysis. Okay, that's why. Now after this, okay, you will find that, okay, index location. Okay, the same thing, you can get over here. Okay, the any subject value, okay, any random row, okay, you can see, but then you will have to add that random row into the list. Like you don't want to go ahead with 1 to 5, you just want one row and the fifth row. You just want a zero index column and the, second index column. So now you can see the a and c, not the a and b, right? Okay, instead of adding the colon, you just mention the comma and add into the list. Okay, now here you can see that. Okay, now okay, we are using a boolean indexing. Okay, because here we just added one condition. We are saying that, okay, get the data, okay, from the data frame. Okay, but this condition is true. Okay, if this condition true, then only get the data. Okay, then what we are checking that, okay, get the data frame dot a, and that a is should be greater than 0. Okay, not in negative. Okay, so let me give you the output. So here you can see that. Okay, see, this is the original data. In the original data, how many values of a are negative? This one and this one, this one. Total three values are negative, and to total three values which are positive one. So here, okay, okay, we got the three values, okay, of the data which are positive one, right? So that's how you can even take the subset of your original data, and see, you can even copy your data frame. See, like many times, okay, client don't wanna change, okay, don't want change in the original data frame. So at that time you will have to use a copy of that particular data, because to manipulate the data, which means you are changing your data. Okay, okay, for doing some analysis, for getting some insight from the data, you need to change your data, manipulate your data, okay, apply some updates in your data for finalize your data to build the model from that data, okay, or to get some insight to some patterns from the data. So for that you need to update the data. So that's why many times, instead of going with original data to manipulate that data to change the original data, instead of that you can do one thing, you can copy that data and you can go further with your analysis, right? So that is again the the important function, okay, which is provided by pandas library. Okay, so see this, okay, how much you can do with the help of pandas and a numpy library, right? So see, this is you can do. Yeah. We just added the one more new column into the data frame, okay, which is the copied data frame, okay, of our original data frame. And we just added the new column, which is nothing but the e column, okay, and that e column is going to be the categorical column or object type. Okay, now here you can see that now you can check again the, okay, is in or not the particular this, okay, you can check that, okay, this 2 and 4 is in the e column or not, you can check like this. Yes, see, okay, you will get that one. Huh? Now here you can see that, okay, you are selecting all rows except those, okay, with 2 and 4. So here you can see that, okay, as you mentioned this term, which means that you are selecting all the rows except these 2 rows, okay, in which, okay, in any certain 2 rows, okay, which rows present these values 2 and 4, okay, you are just not taking these values, okay, not taking these rows, okay, like this. Yeah, we got the data without 2 and 4, okay, in the particular rows. Okay, now after this, okay, here you can see that, okay, the last function, which is nothing but the pivot table. Okay, like it's a very again interesting term, pivot table. Okay, because like in excel you can create the pivot table, and this is very much important for creating the dashboards as well. Okay, like in power bi and tableau it is very important. Okay, let's go and run this for just create the data. After creating the data, here you can see that we are creating the pivot table. Okay, now what is there in the pivot table? Okay, so see, this is my data. Okay, we are using the values which are nothing but the ounces. Okay, index is nothing but the group. Okay, and aggregator function is nothing but the mean. Okay, which means that we are creating a table, okay, which is just categorize or grouping the this particular a b. Okay, like the how many a are there, so you will find that the only three are a are there, so you will get the, okay, we are trying to find out the mean of these ounces of group a, then mean of ounces of group b, and mean of ounces of group c. Okay, and that table will just create by using the pivot table. So let me run this, and here you can see that we just find out the mean of ounces by using it on the basis of different groups a b c. Okay, so again this is very much important. In a one line of code you can be able to do this thing. Yeah, let me run this, and here you go. Yeah, a b c. Let's go ahead and explore machine learning. Okay, how we can implement machine learning, okay, in and you know in different machine cyber security problems. Okay, for applying for solving the problems of cyber security. Yeah, so here you can see that, okay, we'll be talking about this malicious website classification. So let's go over here. Okay, so malicious website classification in this particular, okay, particularly here you can see that the data set. Okay, like see, we just open this particular file. Okay, and here you can see that, okay, this many data. Okay, here you can see that in the data set. Okay, the different things, different columns are there. URL length, okay, length of the URL. And now guys, see here, okay, the URL, okay, URL name, okay, and this is a malicious one, this is the benign one, okay, means genuine one, you can say. Malicious, okay. So here you can see the length of the URL, okay, the number special characters, okay, number of special character, you can see the character set, okay, the server you can see, and lot of data you will find over here. Okay, the lot of data you will find over here. See, you will find the content, you will find the voice country, okay, you will find the state flow, okay, registration date, okay, like this update date, conversation exchange, okay, okay, district remote TCP port, okay. In the last you will find that the type, okay. So the type is nothing but, okay, you will find that, okay, that one is for the malicious one and the zero is for the benign one. Here you will find the one malicious website, benign malicious benign malicious, like this. Yeah, so okay, like we just collected this many columns, okay, and in the end, okay, we label that data as a whether that particular URL is a malicious one or benign one. Yeah, so now here you can see that, okay, when it comes to the data, okay, when it comes to the understanding of the data, okay, so as we did, okay, we imported NumPy library and Pandas library. Okay, as we know, NumPy library is for creating n-dimensional array as well as doing some, some basic linear algebra, or you can say that the finding out the mean, median, mode, correlation, okay, this kind of thing, as well as basic statistical terms. Okay, now what about Pandas? Okay, Pandas is for data pre-processing as well as importing the data sets in various different, sites, or you can say that the various different format as well. You can even read the CSV format data set, HTML format data set, SUV format data set, any different kinds of format data set you can be able to read in the Python by using Pandas package. Yeah, so let's go and run this. Yeah, so okay, this will be the one. Okay, before doing this, okay, let me just restart the kernel and clear all the output, so we'll be able to like the explore more about or explain more about the input, okay, and then we'll see the output. So let's go and run this. Yeah, now here you can see that, okay, this is my data set. Okay, for importing data set, okay, there are few things you need to know. Okay, here you can see that this is the dataset.csv file is where is in the same folder where we have the Jupyter notebook file. Okay, so here you can see that we are using a dataset.csv file. Okay, and this file, okay, this data is in the same folder where we put the malicious website classification Jupyter notebook file. Okay, and that file is over here. Okay, which means that we no need to put any path. Okay, otherwise you will have to put the path like this. Here you can see that the desktop ML for cybersecurity, malicious website classification, %20 is for the space. Okay, and you can see that the some kind of path over here. Okay, if you remove the %20, you will find that the path for malicious website classification, your Jupyter notebook file. Okay, so likewise you will have to add some kind of path over there for this particular data set. Okay, so another way of doing this is to just go over here. Okay, just go over here, fire. Okay, go with the properties. Okay, and in the security you will find that the path. Okay, this one, just copy this. Okay, and paste it over here. Okay, instead of this one, okay, you can paste it over here. Okay, and instead of the forward slash, you will have to convert this forward slash into the backward slash. Okay, because you will find that okay, this forward slash are nothing but the escape character in Python. So this particular symbol is reserved for escape character, as a escape character. Okay, so you can't use this as a, for connecting the path. Okay, so that's why you will have to add the one more, the forward slash. Okay, otherwise remove both the forward slash and put the backward slash like this. Okay, this one. Yeah, and put, okay, wherever you find the forward slash. Okay, then you will be able to run this particular path. Okay, you will be able to read the data set, okay, from of this, okay, where you store your data set dot csv. Okay, like this you can add your, so we don't need this one because we have, okay, this data set already in the same folder, okay, where we save this particular Jupyter notebook file. Yeah, so with the help of pandas pd dot read underscore csv, function, we are reading the dataset dot csv file. Okay, and after this, here you can see that after reading this, we are just looking for the first 5 rows of our data frame, which we just read. Okay, which is nothing but the, with the help of add method. Okay, let me go and run this. So you'll find that the top 5 rows or the first 5 rows of your data frame. Okay, so you can see that the total number of columns are nothing but the 21, and you will see that, okay, now total rows you will find over here which are 5. Okay, if you wanted to see the full shape of your data frame, just use the attribute shape. Okay, data frame dot df dot shape. Let's go and run this, and you will find that total how many rows are there? 1781 rows are there and 21 columns are there. Out of these, okay, 20 columns are the input column. Okay, as we discussed this same, okay, 20 column are nothing but the input column, and the first the last column, which is a type column, which is nothing but the output column. We'll talk about that later, okay, when we'll have to, create a model of machine learning. So here you can see that in the index you will be able to, with the help of information, you will be able to find out, are there any missing value present in the data set or not, right? Okay, as we discussed this in previously. Yeah, so here you can see that how many entries are there. Okay, same 1781 entries are there. Okay, and here you can see that in the first column, how many entries are there? 1781, the same number. 1781, another same number, which means that no null value. 1781, no missing values, no null value. 1781, no missing value. Here you can see that 1780, which means that there is one missing value present in the server column. Yeah, now what about this 969? Okay, many missing value present in this particular content length column. Okay, and around you will find that the around 800 missing values are there. Okay, more than 800 you can find that. Okay, and remaining you will find that only for this, okay, DNS query times. Okay, for this you will find that there is a missing value. Okay, and how much? Only one missing value is present in the DNS query times. Okay, so that's how you can identify this. You can get the terms, you can get the information from your code. Okay, now, okay, what we are doing over here, okay, we are selecting data types. Okay, why? Because you will find that few data points, few columns are nothing but the objects. Okay, if you wanted to go ahead with the object columns, okay, then we just created the one more file for this. Yeah, we have this file. Okay, we have this file here. Again, a more explanation about the data. Okay, the very in a very detail. Okay, here I just added the approach as well, and here you can find that the same data set. Okay, you will find that the same data set as we are looking the same over here as well. Okay, so here you can see that we'll be using all the data set. Okay, not we are removing any, not we are taking only in the number data types. Okay, means the columns which contain the numerical values. Okay, So here for, okay, to shorten the, analysis, okay, we did this thing. Okay, okay, here you can see that. Okay, now we are selecting the data only numbers. Okay, we are just removing the objects data. Okay, we are removing the object data. Okay, why? Because here our aim is to understand how we can implement the machine learning algorithm on a cybersecurity data set, not the aim that, okay, like the, we don't have to do a, like a, we don't have to find out the very good model. Yeah, yeah, that's the main point. But here our main aim is to show you how to implement the machine learning algorithm on the cybersecurity data set. Yeah? And how to identify malicious website. Okay, and how to, you can create the model for that model. Just identify which website is a malicious one and which one is not. Yeah, in the future, right? So this is the sample one. Okay, and you want the, real one, you can go ahead with this. Okay, data frame dot select data types. Okay, so we'll be going with this. Now here you can see that the total columns are how many? 21 columns are there. But how many numbers columns are there? Okay, only 14. Here you can see. Okay, let me show you this thing. Okay, let me create this. Okay, tf dot shape attribute and get the output. And here you can see that, okay, the same number of rows we got. Okay, but we just reduce the number of columns. Okay, now we only have the column which contains the numerical values, not a single column which is object. Okay, here you can see that we just we just drop the character set server column. Okay, like we just drop the, this column, url column, like this. We drop all the columns, those are object one, like the this one. Okay, this one and this one. Yeah, so out of 21 we just drop, around 7 columns. Okay, that's why you will be able to see the only 14 column are there in the data frame. Okay, okay, now okay, after this, okay, let's go and check how many null values are there. Okay, sum wise. Okay, like see here we got the, we got to know that, okay, like there are missing value present in the data, right? There are missing value present in the data, but we don't know the sum. Okay, exact number we don't know how many missing values, because we otherwise we'll have to manually calculate. Okay, just subtract this particular 969 value from the 1781 value, right? Then we'll understand that yes, these are the missing values in this particular column, which is the content length. Yeah, so we'll do the same thing by using this df dot is null. It is checking the, is there any column of data frame, and find out the sum of that. Okay, let's go and run this, and here you go. Yeah, these columns are the numeric column, all these columns. And out of this column here you can find the content length, which is nothing but the 812. Okay, and here you will get to know that, okay, this column contains many missing values. Okay, contains many missing values. Okay, so like there are multiple ways. Okay, there are multiple ways for, filling the missing values, okay, in the particular column, or you can even go for dropping your that particular column. Okay, but we already dropped around 7 columns. Okay, so here, okay, we don't want to drop the columns. Okay, we show you how you can fill the missing values. Okay, because see here how many missing values are there? 812. Okay, total 812 missing values are there. So manually it will take. See, first thing is that you will have to find out the mean of that data. Okay, mean of that content length. Okay, you will have to find out the mean of your column. Okay, then one by one you will have to go and, okay, manually put the mean. Okay, this is the first way. Okay, second way, that yes, you can, yes, put the missing value. or fill the missing value by using mean, median, mode depending upon the type of the data. If the type is a numeric one, you can go ahead with the mean or median. Okay, if the type is more if the type, if your data type is a character, okay, like we just drop all the character data, all the character column. So if is there any missing value present in the character data, so at that time you have to use the mode. Okay, mode is a statistical term. If you wanted to explore more about mode, so then you can search for that term, mode, on a Google. You will get all the idea of the all the idea about mode. Yeah, so here you can see that we are filling the missing value. Okay, so see how to how to fill missing value for this particular 812 missing data, okay, of this particular column, which is a content length. Here you can see that we are just defining the content length, okay, saying that yes, we are doing operation on a content length column only, okay, of this particular data frame. Here you can see that we just selected this content length column by using this data frame. In the square bracket, we just mention the name of this particular column dot fill na. Now fill na is nothing but the fill null values. Okay, na are nothing but also known as a null values. Okay, you can say that the nan as well. Yeah. Okay, fill na, and in the bracket, okay, again we just mention the that particular column dot mean. Means just find out the mean of this particular column and fill that all the missing values with the mean. Okay, or you can say that replace all the missing values which are 812 with the mean of that same column. Understood? Okay, let's go and run this. Okay, yes, we just replace all the missing values with the mean of that same column, and now here you can see. Okay, now we just fill all 812 missing values. After this, here you can see that, okay, we just now, okay, remain with this. So we do one thing, we can simply drop this, okay, because this is a, like this is just a sample to show you how we can, fill the missing value, and we can even go for the dropping the data. Okay, so just uh, just a sample. Okay, this is just a demo, okay, how you can do the multiple things. Okay, but in reality, if you want, okay, if you want to see, okay, so see here, I just wanted to complete all the methods, all the functions, okay, which we are like using for a, in each and every project. Okay, that's what my intention is over here. Yeah. Yeah, if you want a full-fledged like a, full-fledged kind of thing, okay, like a full-fledged project, okay, so you can see over here. Okay, see, did multiple things, okay, created the heat map to understand the correlation, okay, like did the feature engineering for feature selection, finding out the best feature. Okay, we did the smart, okay, for resampling the data. Okay, like see, and then we go for building the model, which is nothing but the random forest, so many models we have, naive based logistic regression, okay, so many models. Yeah. So let's go and drop the data. Okay, the is to just show you, okay, how we can go for the dropping the data. So after dropping the data, here you can see that, okay, okay, we'll just try to see, a basic, visualization, data visualization. Okay, let's go and run this. Okay, seaborn library, this is a, data visualization library. Second one is nothing but a matplotlib. Okay, we have the multiple libraries for visualization, but these two libraries, first one is a seaborn, second one is matplotlib. Okay, so you can use these two library for data visualization mostly in Python. Huh? So now here you can see that SNS, okay, the short name for seaborn. SNS count plot. Okay, now we are just counting the how many data points, okay, how many data points which are belongs to the benign, means the, benign one, which are nothing but the genuine URLs or websites, and how many are nothing but the malicious one. Okay, so let's go and run this, and here you go. So you can see that, okay, you will find that the, like maximum number of websites are the genuine one, okay, which are nothing but the type 0, and one is nothing but which is representing that the malicious website. So you will find that very less websites which are malicious one, right? So always in real life as well, okay, you will find that, okay, you will get to know that, okay, like if you are let's say if you are like in a day you are, okay, going on a random websites, let's say 100 random websites, but out of those 100 random website, okay, very few website like a 2 5 websites which are malicious one, right? Okay, out of those 100, okay, or even for like for some day you may not get any malicious website as well, okay. This is totally depends on your search history, what kind of search what kind of product or what kind of services you are searching for on the internet. Yeah, now here you can see that, okay, here, okay, the main thing is that the as I told you, okay, in the machine learning we are just splitting our data, okay, into the input data and our label data. So here you can see that the input data and output data, or you can say that the independent data and the dependent data. So that is the two different data set, or you can say that the label of this particular data. Okay, this y is nothing but the label of this particular data in short. Yeah, so let's go and run this. So you just split it the data into the two different data set. Now you have the two different data set. First one is a x data, second one is a y data, right? Okay, now see we are doing the same thing in the second two, okay, in the next two applications as well. That's why I'm explaining this much in the first application. Now here you can see that after splitting the data into the input data and output data, so now here you can see that, okay, the main thing is that for before building the model, okay, how to check that particular model that we built, okay, is that particular model is good or bad. Okay, so for checking that particular model is good or bad, we need to split our original data in two different data set. Okay, first one is a train data set and second one is a test data set, which means that we are building the model on the train data set and we are testing the our model on the test data set, right? So the name you can find that the synonymous name, okay, for training the data, okay, for building the data we'll go with the train data, and for testing the data we'll go with the test data. Okay, that's why I just use these two names, train and test. And here you can see that we already splitted our data into x and y. So now we'll have to again split our data into two parts. Okay, like first we'll have to split this data into two parts. That's what we did over here, x train and x test. And again we are doing the same thing with the help of y data frame in a one line of a code. Okay, like y train and y test, which means that just by using this line of code we are splitting these two data set into the four data set. Understood? Okay, and the order for this writing this thing, okay, x train x test, y train and y test is very much important. Okay, and here you can see that we took this function train test split from the module of sklearn library, which is nothing but model underscore selection, model selection module of sklearn library. Okay, so here you can see that x and y, the test size is going to be the 30% of overall data, which means that we are splitting our data into the training data as a 70% of our original data into the training data, which is totally randomly selected. Okay, and the test data is nothing but the 30% of our original data, again in the test data as well, totally randomly selected. Yeah, let's go and run this, and here you go. Okay, now after this, here you can see that the main thing, okay, that after understanding that the count plot, here you will find that there are two classes in the target column. Type is nothing but the target column. Here you get to know that. Okay, target column is nothing but the label. Okay, so here you can see that there are two labels only. First one is a genuine label, which is represented by 0, and the malicious label, which is represented by 1, right? Now here you can see that in our data set, okay, more number of data is from the genuine data, okay, is a genuine websites, and very less amount of data is a malicious one. So in the model building part as well, you will get to know that if you, instead of going with resampling, if you directly going with the building the model, okay, your model showing a high weightage, or for predicting correctly, okay, this data which are nothing but the genuine data, because you will find that the more number of data are from the genuine websites, okay. So which means that, okay, model is biased towards the predicting genuine website, not towards the predicting the malicious website. So we don't want that kind of model, okay. We want the model which predict the website in a correct way, okay. If that website is a malicious, that then model should able to predict that website is malicious, right? Otherwise there is able to predict correctly any website is malicious or genuine, so why to go ahead and create that model, okay, and why to like spend that much of money for creating the model, right? Resampling, okay. Now here you can see that, okay, now these are some matrices, okay. With the help of this you will be able to some find out the accuracy, okay, of the your model, okay. Now in short area under the curve, you can say that the, okay, the curve is nothing but, okay, you will find that the 87%, if the value, okay, you will always get the score value in between the 0 and 1. If you get the score value which is close to 1, so you can say that model is good, otherwise you can say that the model is bad, okay. So like there is a subjective choice for setting a threshold value, okay, but I set a one threshold value. Well, let's say if the AUC value which is 0.85 or 0.8 greater than that, so you can say that model is good, okay. In short you can say that the interpretation for this particular value, so here you can say that the 0.87, okay, which is nothing but more than 0.85, so you can say that model is quite good, okay. Let me show you the accuracy for that, so you will understand that, okay. So this will be nothing but the confusion matrix, okay. We'll talk about this, okay. But before this, okay, let me wanted to show you the classification report, then we'll talk about the confusion matrix, okay. Because confusion matrix is a term, in the name itself you will find the confusion word is there, okay. Here you can see that when, okay, we were here. Now here this is a very small visualization of confusion matrix, okay. So this is a visualization of confusion matrix, okay. uh, Here you can see that the true false, okay, to show you, okay, why is there, okay. You will find that the predicted values means predicted values from the model, and these are the actual values from the original data set, okay. You can see that the 451, okay, which are nothing but the genuine data, or you can say that the true negative value, which is nothing but which are from the type 0, okay, true negative, which is nothing but the actual data points are from type 0, and model predicted that those data points are from type 0, the same data point, okay. So there are 451 data points are from type 0, okay, and model predicted as they are from type 0, so this is nothing but true negative. 0 is considered as a negative class, so that's why I'm saying that it's a true negative, right? True negative, which observation are from class 0, observation are from negative class, observation are from type 0, and model predicted as a they are from type 0, they are from negative class, that's it, okay. That's why true negative. The same is for the positive class, which means the observation are from the type 1, okay, also known as a positive class. So total 52 observation are there are from the positive class, also known as model also predicted as they are from the positive class. And then 18, okay, and these values 18 and 14 are nothing but the false positive and false negative, which means that, okay, 18 observation, okay, let's say, okay, for explaining this, let me just go ahead and create a classification report, okay. We'll explain this term over here, okay. See here, total number of data points from type 0 is nothing but 469, and total number of data points from type 1 is nothing but 66, right? Total number of data point in the analysis for building the model are nothing but the 530 point 35 point. Okay, so here you can see that. Okay, if you sum this, so you will get the true all the negative data points. Okay, see 469, right? Okay, so this is nothing but false positive. There is a f1 score for class for type 0. Okay, for class 0, here you can see that 97%. Now 97%, which means that again the if it comes to score, so the value of score will be between 0 to 1, and if the score value is tends to 1, so you can say that, okay, the that particular point is good. Okay, okay, so here you can see that. Okay, now this 0.97 says that model is able to predict type 0 97% of the times correctly. Okay, okay, and the same for type 1, model is able to predict 0 point or the 76% of the time type 1 data correctly. Okay, that is the interpretation of this term. Okay, now, okay, why I told you do not go into this, because, okay, f1 score is nothing but the harmonic mean of precision and recall. Okay, is nothing but the harmonic mean of precision and recall. Okay, so instead of going with precision and recall, simply see this one. Okay, simply see, this is a shortcut for understanding the whether that particular model is good or bad. Okay, so you can see over here. Okay, you can see this thing. Okay, the model is good. Okay, but here you can see that f1 score is bit less, okay, as compared to type 0. So here you can see that you will have to, okay, if you wanted to update the model, you can go ahead. Okay, and you can able to update the model. Okay, just add the gamma value, and you can be able to update the multiple parameters. Okay, like the booster, you can be able to go ahead with the multiple parameters. These are nothing but the n estimators, which means that the number of trees you have to take into the account. Okay, this is totally based on the tree based methods, also known as ensemble techniques. Okay, so this is the one of the most popular algorithm you can see, which is nothing but the website malicious classification, and we created the model which gives us the accuracy of around 94%. Okay, without any you know without any android malware detection. Okay, malware is nothing but the malicious activity just by using some software, some link, anything, right? So that's what we are just finding out over here. Okay, now here there is some explanation. Okay, about the data you can find over here. Criminal activities, which are cyber criminal activities. Android malware analysis, here you can see that. Okay, there is one static analysis, one is dynamic analysis. Okay, there is some differences I already recorded over here. Okay, if we talk about the static analysis, so you can say that one popular example like this. Okay, when you are installing one app, which is a flashlight app, and that app wants access to your call history. Okay, there is no need to access the call history of your, okay, to the flashlight app. Okay, why the flashlight app needs the your call history? Okay, so that is nothing but your static analysis. Okay, so here again you can do the multiple packages importing part. Okay, sklearn, you can see the most important package, okay, of machine learning, then pandas and seaborn for data visualization. Let's go and run this. Yeah, and you can see over here. Okay, we are doing the static analysis, only one algorithm we are running, and a remaining algorithm you will have to run. Okay, okay, so see, exploratory data analysis we have to do. Okay, first we have to read the data, which is the train data. Okay, here you can see that after reading the data, we are doing a data wrangling task. Okay, value counts, finding out the value count. See, this is a balanced data, not the data not the data which is imbalanced, like in the previous case. Type 1 type 0 is a very high data. Okay, but here there is no that is not the case. Okay, case type 1 has a 199 values, same for the type 0, right? Now after this, here you can see that find out the shape. Yeah, then you can do the, yeah, we are doing the, yeah, sorting. Yeah, because we already did this thing, so no need to explain this thing. Okay, and we are doing the, again, the sorting for the benign class. See, and we are doing some, data visualization part by using matplotlib.pyplot. This is the very popular data visualization library in Python. Okay, let's go and run this, and here you go. Yeah, now here you can see that. Okay, what we are doing, we are just sorted the values. Okay, that's what we are showing you over here in the visualization. Okay, right? Now after this, okay, you can see that, okay, we are just going for the modeling part. That's why we are splitting our data into the train and test. Okay, and the test size is 20. Okay, so let's go and run. Okay, it's an assignment to check the, why we use a random state. Okay, over here. Okay, there is one very very popular thing. Okay, very important part for using random state over here. Okay, here you can see that, for decision tree accuracy is 94%. See, okay, if you use a random forest, so and the XGBoost classifier, the I guess accuracy will be more than this 94%. Okay, for dynamic analysis you will find that, again the, multiple things, and in the modding part you will find that not much. Okay, for logistic, for Gaussian naive Bayes, here you can find that for Canaan you will find that the 89. So this is Android malware detection. That's how you can apply machine learning, okay, to find out the malware in your Android device. Yeah, okay, the last one, which is nothing but the fake news detection. Okay, now here you can see that in the fake news detection, okay, you get to know that again we are doing the same thing. Okay, we are importing the pandas to read the data frame. These are my column names. Okay, if you get to know that in the fake news data frame, okay, data set, you will find that there are no column names, so that's why we just added the column names over here. Okay, let's go and run this. Okay, and here you can find that, okay, the head, you can be able to see the first 5 entries of your data. Okay, now here you can see that, okay, we are saying that if the language equal to English, okay, we are just instead of going with other language, okay, we'll only take the data set which is from the English language only. Yeah, and we are dropping the NA values instead of seeing any NA value present or not. Yeah, so it's very easy to see the check whether is there any missing value present or not by using the df, means a data frame dot info method. Okay, you can go ahead and check that one. Okay, so simply to reduce the time. Okay, that's why I did this. Okay, now here you can see that we are dropping the language column as well. Okay, because here the main thing is that the aim is to just find out the, build the model which can predict, okay, the news are fake or not. So the language column is not important. Okay, that's why we are just removing this, because in the first, okay, we just took the data which is from the which is of only English language. That's why we are just removing that particular column. So you will find that the language column is going to be a constant column, because after taking the language equal to English, which means that in the English language you will find that in the language column you will find that all over English. Okay, all values are nothing but the English for this particular language. Okay, so you will find that, okay, that's why we just drop the language column. Okay, now here you can see that we are creating a function which is nothing but the add feature. Okay, we are adding a feature, okay, which is nothing but the first starting with the initial feature which is equal to 0 and feature map. Okay, here you can find that. Okay, and here you can see that we are adding the feature as a fake or real. So let me go and run this. Okay, now here you can see that the article type, okay, again the fake and real, right? So here you can see that the fake and real. Okay, which means that we are just saying that yes, okay, just just convert this into the fake and real, fake and real, fake and real, like this. Now let's go and run this. Okay, now here you can see that, okay, we are applying over in this cell, and we are applying on the data frame, on our data frame, right? And here you can see that on the type we are applying that one. Okay, and then you will find that, okay, we'll be getting a final, the target column, which is nothing but the type column, right? And after getting a target column, let me show you. Okay, the, you know the head data frame, data frame dot head. Okay, and let's run this. And here you can see that in the last you will find that the type column. Yeah, type column. Okay, you will find that, okay, the fake and real column. Okay, the fake and real news. Okay, you can find that the text in the news, the title. Okay, like this. Yeah. Now, okay, after getting the input and output data, the main thing is that split the data into the train and test. So by using model selection of sklearn library, we are splitting the data into training and test. Okay, what we are doing, okay, this is a natural NLP data, okay, natural language processing data, which means that totally text data. So to analyze the text data, okay, we have the different techniques. Like, let's say for feature extraction in dot text, which means that for see, manipulating the text data, we have the TF-IDF. Okay, we are converting the text data into the numeric one. Okay, the term frequency inverse document frequency vectorizer. Okay, the long form of this TF-IDF vectorizer. Yeah, we are applying this on the text and the title data. You can find over here, and we are doing the same thing on the train data. See, applying this on the train data, we are doing the same thing. Okay, the after fit transform, you can see that the text, we are doing the same thing for the thread title, the second column, which is the text column. Okay, because the main intention is to just detect the fake news. Okay, so these two things are very much important. First one is the text in the news and the title of the news, right? So that's what we are doing here. We are just converting that text data, because laptop or system is not able to understand the text data. Okay, so that's why we'll have to convert the text data into the numeric data. Okay, and with the help of TF-IDF term frequency inverse document frequency vectorizer, we are converting that data. Now we have the SciPy, okay, SciPy library, and we are importing the sparse matrix. Sparse matrix is a matrix of 0 and 1. You will find that in the sparse matrix, you will find that most of the 0 value and very few 1 value. This is some kind of information. Okay, like we just converted each word. Okay, and if the one word, this, let's say, print, is present in this particular text, so we can say that, yeah, so in the sparse matrix you will find that in the print column, in the first row, you will find that the one value, otherwise zero. Yeah. Okay, let's go and run this. Okay, sparse matrix. Okay, so here you can see that after after applying sparse on multiple columns, okay, like see here, spam scores, okay, replies count, participant count, likes, comment, shares. Okay, after applying that, okay, the sparse matrix on this, okay, let's use the stacking, because see, we just got the multiple columns now separately. Okay, now we wanted to merge this column again. Okay, so that's what we are doing by using the horizontal stacking. Yeah, and here you can see that again we are getting the values. Yeah, now what we are doing, we are applying a random forest classifier, one of the most popular machine learning algorithm, which is also known as a bagging algorithm, also known as ensemble learning algorithm. Yeah, so now after after creating the random forest, let's go and run this. Okay, and here you can see that, okay, after building the model, okay, let's go and predict the data. So before predicting the data, you have to do the same thing. You have to manipulate your test data from text data to numeric data. So that's what we are doing over here on the test data. Okay, and lastly, you will see that the score, which is nothing but the accuracy for your machine learning model, which is nothing but the 99.9%, right? Okay, so this is how you can go ahead with. Okay,